Hello, this is a video demonstration of the operation of confidence intervals, the Aqa S1 syllabus, and I'm using the June 2013 question 6 as an example. As ever, we start by reading the question. Okay, the weight, x kilograms, of sand in a bag can be modelled by a normal random variable, so that's normal, with unknown mean, and with known standard deviation of 0.4. So that's our background information. The sand in each of a random sample of 25 bags from a large batch is weighed. The total weight of the sand in these 25 bags is found to be 497.5 kilograms. So that's for all 25 bags. And the instruction is construct a 98% confidence interval for the mean weight of sand in bags in the batch. Okay, that's pretty straightforward. So they're asking us here to find the mean weight of sand in the bags. And our approach to this is to take the information they provided us, the sample mean, and then create a range from the sample mean using the standard deviation they've given us. Okay, so let's work out the sample mean first, and we're going to describe that as x bar. That is the sample mean, not population mean. And we've got here that for a batch, the 25 bags weighed 497.5 kilograms, and that's across 25 bags. So the average for an individual bag is 19.9 kilograms. Okay, so that's going to be the center of our confidence interval. We haven't got a mean, so we're starting from that. That's our sample mean. Okay, second part, next part we need to work on is what's the standard deviation? Well, we've got a sample here, and what we're interested in is the standard deviation of the sample mean. And from the formula book, we know that that's the population mean divided by the square root of n, where n is the number of items in the sample. So here we were told that the standard deviation of the population was 0.4, and we've got a square root of 25, which is so that's 0.4 over 5, which is the same as 0.8 over 10, which is 0.8 kilograms. Okay, so in reality we have, excuse me, gone too far there. We have, from this information, we know that the sample mean distribution is normally distributed, and we're going to start with a mean of 19.9 kilograms and a standard deviation of 0.08 kilograms squared. So that's going to be our distribution of our sample mean. Okay, so now let's look what we can do with this. We know it's normally distributed in this example because they told us that the original population, that's just hop back, as normal, was a normal random variable. If it hadn't said that, we would have to look at central limit theorem, but we don't need to apply that here. Okay, so now let's draw ourselves a little diagram of what we're looking at. We're entitled to use a normal distribution because it told us our parent was normally distributed. We've worked out that the mean for our sample mean range is going to be 19.9. We've got our standard deviation of sample of 0.8, and they've asked us to create a 98% confidence interval. So we're entitled, because they told us it was normal, to use our normal Z distributions and our probabilities. So let's get our calculator up on the screen. Let's have a quick look. Okay, so off into the stats module, distribution, normal, inverse normal, because we're going from probability to our Z values. So let's have a very quick look here. So we want a central tail, the center. We don't want to be left or right, because we're going to be in the middle here, and we want an area of 0.98 is the area, so that's why 98% confidence levels. We're looking for a Z value, so we leave sigma as 1 and mu at 0. And we press our execute button, and we get those two numbers. Those are our two Z values, the two extremes. So we've got minus 2.326 and plus 2.326. So let's mark them on our sheet. And of course, these are number of standard deviations from the mean. So that's our number of standard deviations there. So we can therefore, and we knew what our figure was for our standard deviation, so we can now work out that our confidence interval is centered at 19.9. and then it's plus or minus our Z value here, critical Z value 2.326, and then multiplied by our standard deviation and the population mean, which we got a 0.08, which equals 19.9 plus or minus 0.2. So our range is therefore, the interval is between, so it runs from 19.7 to 20.1 kilograms. Pretty narrow window, thanks to the fact we can use the normal distribution. Okay. Finally, here's a quick summary of confidence intervals and how to use them for how to calculate them for this purpose. Just remember that if the parent is normally distributed or the sample is large, i.e. over 30, then the normal probabilities can be used. So the CI, confidence interval, will be the X bar, the sample mean, plus or minus the normal Z values for the percentage test that you're carrying out, and that's centered around the center, times the sigma of the population divided by the square root of n, where n is the sample size. I hope that's of use to you, and thank you for watching.